I am here at the AI Summit London with Tom Wilcock, who is the Director UKIMEA Digital Services Leader at Arup. Tom, how are you doing?
Really well, thank you, Tom. Great to be here. Really interesting event so far.
Brilliant. So you have had a speaker slot at this year's event. Do you want to tell me what that was about?
So it was a session covering the way that AI can be used to solve really tough problems in sustainable development, particularly in the built environment.
Okay, and so obviously a gargantuan challenge globally. What are the kind of use cases that you're especially interested in terms of building out that kind of service offering?
So the built environment obviously is about building things, and those buildings or infrastructure take shape over many, many years, sometimes decades. And so we're interested in the way that AI can change the way that whole asset life cycle unfolds. So from the planning stages all the way through construction and into ultimately reuse of buildings and infrastructure. So we've got we've been talking today about sort of specific use cases at each step of that journey.
Okay, interesting. And so I guess there are some pretty ancient legacy systems at play, certainly in the planning world, I imagine, but I guess all the way through that sort of life cycle. So like, where are the areas that let's take planning as an example, as a starting point. What are the aspects of planning that are particularly sort of ripe for innovation and digital transformation?
Yeah, great. So when we think about, let's say, city planning, there are traditional approaches that will tend to model individual systems within a city. What we're finding with AI technologies is that we can consider systems at multiple scales simultaneously. So to take an example around water and flood management, traditionally in a city, that would be controlled through sort of human intervention, what we call grey infrastructure, so physical systems that we build. By using satellite data and then AI on top of that, we can actually understand the way natural systems contribute to flood management and therefore reduce the amount of physical man-made systems that we have to introduce by up to about sort of 30%.
Wow, that's very, very cool. So you're essentially imaging cities from above with a satellite, and then you're taking all of those, photographic data points?
Yeah.
Or is it?
Yeah, down to the sort of pixel level.
Wow, okay. And then you're feeding that into massive models to understand how the water is moving around the city.
Yeah, so we're combining that insight with modeling of sort of catchments. And I guess the critical thing is that what we've not been able to do previously is think about, what your front garden might contribute at a city level, all the way up to the whole regional sort of water flow model. And it's our ability to kind of connect those two things together that's enabling us to kind of, as I say, reduce the amount of intervention we might have to make.
Okay, interesting. And so where's the line then in that? Because a lot of that, I guess, there's statistics and there's kind of data analysis. Where's the line where it's now, an AI solution rather than a kind of traditional, like data analytics solution?
Yeah. So I think that line probably is a grey one. I think what we think about in this context, that the step has been really into machine learning, and that's one that's been becoming ever more sophisticated over the last decade, and that's allowed us to create models that, in this example, allow us very quickly to classify land. Right, so we can there's two technologies coming together really, quite cheaply available satellite imagery, and then our ability to automatically classify land. And so it's the use of AI that's doing that, and that's it is ultimately a statistical process. I mean, all AI is, but it's a sophisticated statistical process that's been trained and then is able to make that classification without human intervention.
Okay, so essentially it's pattern recognition and just scaling up relatively straightforward processes or at those different degrees of revolution.
Yeah, that's right.
I guess.
Yeah, in this example, that's exactly right. And one of the things I talked about briefly this morning is that some of the techniques in AI have been around a long time, and it's exactly as you say. So the availability of data at scale, but also computational power at scale. That's taking things that were sort of nice research ideas and in our world, turning them into useful tools that can actually change the way we design a city, for instance.
Yeah, I guess you've probably got an almost tangential challenge, although, not tangential in sustainability, right? Where are you thinking about how you're balancing your energy usage on the back end with your AI systems and balancing that against the kind of impact that you're able to make, at the sort of, not at the coal face, that's a really bad metaphor, but, at the sort of front end of what you're doing.
Yeah, absolutely. So you're right. We think there's lots of positive things we can do and are doing with the tools. But as with everyone, we need to be conscious of the impact that our usage has on through data centers and all of the infrastructure that's required to run these models. I guess I'd say a couple of things on that. We actually design data centers, so we work with a lot of the major data center providers to try and manage and reduce the energy consumption of those facilities. Ourselves, we're also very conscious of the way we develop software and code, including in the AI space, to try and reduce the amount of energy consumption that they have. So to make that sort of a bit more real, spinning down systems whenever they're not needed and spinning them back up and designing that into the code that we're developing.
Interesting. Because I suppose there's like two ways that intelligence can scale, right? One is with just net energy, and then the other is through efficiency, right? Where you're doing more with the same amount. And so I guess you're presumably working more on the efficiency side than the kind of dramatic scale up of energy usage.
Yeah,
a lot of the kind of foundation models that employ.
Yeah, that's right. And so we use some of those models in the same way that other large organizations would, but a lot of the models that create value for us in our kind of project work are smaller. And again, that's one of the things we talked about this morning. Actually a nice kind of handover from the previous speaker around something that's exciting me a lot, which is small language models. Partly for that sustainable development reason, that they are much more energy efficient to run, but also they enable us to create they will enable us to create more tailored models that solve particular problems in our sector and for our professionals, which can be quite niche. So they're not necessarily the kind of the areas that the big tech players are focused on. And so the advent of those small models, we think, is a really powerful direction for us and other professional services.
Interesting. And so with small language models, then presumably they're also able to run more locally than the kind of foundation models that people are making API calls to and all of that sort of stuff. They're running more locally to your organization.
Yeah, that's right. So the great example again in one of the presentations today of a model that with a powerful laptop, you could run it on the laptop.
Wow.
And so to me, that's a really interesting area of research. And I guess one of the other things that characterizes the excitement in this area at the moment is the speed with which things are moving from research into practice. And as an organization whose business is designing cities and buildings and making better places for people and the planet, it's that impact that we care about. So be able to see things in research and then 6 months later be able to kind of put them into practice is unbelievably exciting.
Yeah, for sure. And I suppose when you're looking at developing these small language models, and you've raised a tangent that I'm now going to I'll go down rabbit holes because I love all this stuff. But I suppose you're just essentially when you're training these small language models, there's a load of stuff that large language models, foundation models are trained on that is just simply irrelevant to almost by definition, like 99.9% of use cases.
Yeah.
Right? So you're just being very focused on the stuff that you need.
Yeah, that's exactly right. And so, that I think is I think it's going to be an important direction of travel for our industry. Another kind of key concept that I talked about in the talk today was the use of surrogate models. And I'm not sure whether you're sort of familiar with these, but it's basically a mathematical approximation of a complex system. It's really valuable in the world that we operate in, where we make design decisions quite early on in a project. And those decisions can have a really material impact on the cost of a project, but also the environmental impact of the project. Now, when you make those decisions, you don't have all the information that you would want because it's by necessity early in the project. With a surrogate model, you can take heavy simulated models that we've been using for decades and train an AI model that enables you to make much quicker predictions about how that system might work. And so to kind of put that into a real example, I talked earlier about the way we use this in wind design. So wind is a really complex phenomenon. You will have experienced this as you walk around a city. You'll get sort of wind tunnels. That's a result of decisions that were made decades ago in terms of the placement of buildings and the size of them. We have developed, I should say, a surrogate model that enables us in real time to predict what the wind flow will be based on the position and scale of a cluster of buildings. Historically, that would have taken 5 years to kind of do the level of analysis that we're doing now in in an hour. So it's just a really good example of combining sort of older numerical approaches and coupling them with AI to bring more information into the design process.
Really interesting.
Sorry, that was a bit of a tangent.
No, it's great. I love it. I mean, I'm sort of thinking now, and this is a real tangent. Can you funnel the wind and then put turbines in the funnel so that you're kind of creating a virtuous cycle?
Yeah, interesting. So, I mean, you do see attempts, right, at putting wind turbines into urban contexts.
Yeah.
I think that generally doesn't create energy at the sort of scale that we need, but you do see that a little bit.
Okay, all right, cool. Well, just spitballing here. Yeah. Well, that's super interesting. And so when the kind of, so you're advising cities, governments, local councils, or like private developers?
Yeah,
all
of the above. Yeah.
Okay.
And so I guess the kind of the critical follow-on point is that these models enable us to make better informed decisions, but you still need expertise to make sure you make the right decisions.
Right.
Again, I emphasized this earlier today that it's enabling us to explore solutions we might not otherwise have done. But then, because the minimum viable product in our world is a building or a bridge, and those can't fail, right? So we have to take an approach to absolutely work through the engineering, the kind of critical physics-based engineering processes to ensure that those things, when they're built, are fit for purpose, safe, and create positive impact on the environment. So these tools are not replacing the need for expertise, but they're enhancing it.
Right. Yeah, because I imagine that you're presumably having to plug into other tools that, like the architectural CAD design tools that are kind of running all of that physics and, to make the bridge stay standing, right? So you're plugging directly into those, are you?
Yeah, so I think it's really important to say that the way we see value from these AI tools is as part of a broader set of technologies, not just standalone. So you're absolutely right. Connecting them to both the ways that we document and visualize solutions, but also the kind of the physics-based packages and products that we use to test things. So yeah, absolutely, those things are getting knitted together. It's not all sort of completely seamless, but that's the interface between those is pretty critical.
Awesome. Okay, so what are you working on? What are you excited about over the next year, 5 years, 10 years? Like what are the big projects that you're working on right now?
So in terms of that time scale, it is a really interesting facet of what we do. That decisions that we make now will unfold over decades. And so to pick a specific example of a project, I think that trying to think which is the best one. So I'll talk a little bit about some of the work that we're doing in energy. So actually another speaker who was here as well from the National Energy System Operator, we've been working with them on creating the data sharing infrastructure for the UK's energy system. So this is not the use of AI at the moment, but it's a critical foundation to change the way that the grid is able to deal with distributed demand and supply as we shift towards a renewable grid. And so the reason I've gone for that example is because it's a really good example of something foundational. So putting in that data sharing infrastructure will enable, in the medium term or the short to medium term, companies and consumers to interact in a different way. And in the longer term, I think we'll set the foundation for sort of AI models across that system to change the way that we manage supply and demand in that context. Right. So it's a really big kind of national scale problem, but it's got some quite interesting kind of governance requirements to put in place now. So a good example of something where foundational work now, I think, could have an impact for decades to come.
Sure. Yeah. I mean, the energy transition, I guess, has so many different facets to it. I guess so. And the bit that you're focusing on is essentially the construction of the energy infrastructure and how you can best manage the way that it's built.
So actually, in this example, it's the frameworks. So I sort of, this feels maybe like a slightly esoteric example. It's the frameworks that will enable data sharing. So I could give you another example of something more physical as well, because I guess one of the things that's interesting for us is that we work to design, but also to advise in the built environment. And so we're connecting expertise from the way things actually operate and bringing it back into design and advice processes.
Okay.
So that was a kind of an
yeah, I'm with you. Yeah. So okay. So let's what kind of built environment projects are you currently most excited about?
Yeah. So on that front, I think that I'll go to a different sector and think about the work that we're doing in water.
Okay.
And so we've over the past few years, the sort of changing availability of data in water networks is enabling us to both model the way sewage networks operate and to think about using some machine learning techniques to predict what's happening, both from a kind of a sewer blockage perspective. And again, this doesn't necessarily sound very sexy, but it's got a really big impact on the way that a society functions. But it's also enabling us to do things to do things like predict the spread of viruses. So using sort of epidemiological models on top of engineering models with machine learning, enabling us to predict from samples in the sewage the spread of things like COVID.
Wow.
So yeah, that's again a big systems problem.
Well, and I guess in the UK, a lot of our we're really going on a sewer tangent now, but a lot of them are like Victorian, right?
Yeah.
So is there like a event? You talked about kind of like changing the way that we use infrastructural assets. I guess that's a prime example of that, right? Like very, very old kind of infrastructure that presumably nobody's planning on updating anytime soon. Does that present a particular challenge?
Yeah, so I think this is one of the big needs, coming all the way back to the sort of sustainable development and the impact that we can have as designers. Absolutely, it's a challenge and an opportunity. So roughly 80%.
Spoken like a true entrepreneur.
So roughly 80% of the building stock that we'll have in 2050 is already here, and so there's a need. It's not just an opportunity; it's a critical need to think about how we can extend the life of those buildings, repurpose them, and ensure that they contribute positively over the next sort of 15, 20 years. So again, actually connecting that to the AI front, one of the examples I gave today was some work that we did on wind turbines and extending the life of offshore wind turbines. So combining engineering data with machine learning to enable us to predict with much more information the likely lifespan of a turbine. And what that's enabled us to do is extend the useful life of some of those turbines by 15%. Wow. And that's got a direct carbon saving and a cost saving as well. So it's a good example where cost and carbon are both benefited at the same time.
Yeah. Oh, well, I mean, we're in the perfect place for it, right? Tobacco docks. There's no tobacco here, right?
This is a great example of how something can be reimagined, but it does need that kind of imagination to think about how you can repurpose something that was designed in one time for one thing, but can serve brilliantly, I think, as tobacco dock is in another time for another purpose.
Yeah. Are we particularly good at that in the UK? I feel like we have lots of places like this that have been like renewed and transformed into something new. Would you say that we're a kind of leader in that kind of way of thinking, being such a historic city?
Interesting. So I don't know. What I would say is that we've got fantastic examples of it. I haven't sort of rigorously looked at that, but like we've definitely got fantastic examples of it. And I think because if you take London as an example, a city that grew organically, it wasn't planned in the way that sort of more modern cities were. It definitely creates a rich fabric for those sorts of repurposing. but also I think is a good example of how sorts of technologies we've been talking about can change the way we design. It gives you it gives you the opportunity to understand the way things are really working, and to kind of pick away at assumptions that can introduce conservatism in normal design processes. So whether we're leading, I think we're certainly up there. But yeah, I'm not sure that I'm not sure there's a league table on that front.
So is there anything that we haven't discussed that you feel is important? Any themes of this year or anything that you're working on that you'd like people to know more about?
So I think probably the three things really. One is that delivering sustainable development is complex, and so we really care about outcomes. So the technology, I'm here talking about technology because of the outcomes it can deliver as opposed to just the technology itself. And so that's the first thing. We can deliver better outcomes with this technology for sustainable development. The second one is really around collaboration. That the technologies and the data that we need to make these big changes and to have the right outcomes don't exist in any individual organization or sector, and so we need things like the data sharing infrastructure to bring companies and sectors together along with governments to challenge some of the ways that we've historically worked separately. And then the final thing is that I think these tools are enhancements for creativity, and so the need to have domain expertise really connected into the design processes when the MVP that you're dealing with, as I say, can't fail, is really critical.
Brilliant. Well, look, thanks so much for joining me.
Great.
Thanks, Tom.
Cheers.